So hello guys, I'm starting lab 2 of ITSM. In the previous video, I discussed about introduction of ITSM and components of time series analysis. And now I'm moving towards lab 2. In lab 2, the object is the real data is related to time series. You can see we have already discussed what is time series, the data in which we collect the data in an equal length of time, equal interval of time. So you can see here in the question we have years. It is an equal length of interval time like 1998 and 1999. And population is change. So what are the objective of the question? Plot the above data set. So we need to plot this time series data in the first part, and in the second part plot the sample mean and standard error. Plot the ACF and BACF for sample mean. Part D, apply transformation and remove seasonality. Part D, apply auto, progressive, and moving average. Part F, fit Y a model with different legs. So I'm going to type this data in ITSM. No, I need to start with Excel. Here the instruction given in the lab. Open the Excel spreadsheet and write all the data in the spreadsheet without error because it is a univariate data. Then this spreadsheet is saved into the type of CSV. We need to save file type as CSV if we are dealing with ITSM. So I'm going to write all the data in Excel. So you can see this picture, I'm sharing Excel. So I'm typing the data. So I write all the data. Now I'm saving this file. You can see CSV MS-DOS. Now I'm saving name as lab2. Now I'm opening. So I am now opening this file app. So I plot this data. Now you can comment on this graph like this graph. In this graph, seasonality is present and graph is in upward trend. That is very simple comment for this graph. You can see graph is in upward trend and seasonality is present. So the part 1 is done for lab 2 and now moving toward part 2. In part 2, plot in part 2 we need to collect information like sample mean, sample variance, number of observation. We need to write each and everything in the practical like data, observations, sample mean, variance, and model. So this is our part 2. Now I am going toward part 3. In part 3, we need ACF and PACF for sample. The abbreviation of ACF is autocorrelation function, and abbreviation of PACF is portion autocorrelation function. So how we can calculate this? For calculating this, we need to click on statistics and click on ACF and PACF and click on the sample. So we got our ACF and PACF. So we need to draw these graph in exam. And we need to write the comments on it. So I'm explaining the comments for it because it is easy to draw. Everyone can draw it, but commenting is very difficult. So in ACF, I'm starting with the ACF. In ACF, it is cyclic or mirror image. ACF also shows the autoregressive model. The two line or spike are always higher. All spike point in the interval. There are 19 lines or spike in the interval. So we have 19 lines. We have 19 observation, and we have 19 lines, and we can comment accordingly, like we commented in the graph in the part one of the lab 2. So we comment in lab part 1, like seasonality is present and the upward trend we can observe easily, and here we need to comment same, but we are seeing that some observation are down and some observation are above the line. It means that it is a mirror image. So we need to come in whenever see the pattern like this, increasing and then decreasing. So we can say it is a mirror image. And we noticed two lines spiked above. Two lines are very high. So we always mention in our comments that our two lines are very high. This is the way we can comment here. Now moving toward PACS model. In PACS model, there are 33 spikes are drawn. In graph show two high spikes. Here we can clearly see the two high spikes, and we need to mention it in comments. All spikes are within the interval. Expect these two. Only two are outside of the interval. We need to come in like two lines are outside the interval. Even if there are 3 or 4 or more, we can say these lines are also outside of the interval and the rest lies inside. If the picture we see here. PACM model shows the moving regressive model. The one line which is downward and higher. It does not touch the interval, but it shows it's making best moving average. The one line, you can see this line. The one line is downward, but it does not touch the interval. So we can comment that if one line is downward and does not touch the interval, it is the best moving average. So comments are very simple here. Now we are moving to our next part of transformation. In transformation, we need to click on transform. Transform and click on box. So we can transform like put 0.3, then click OK. It appears in the graph. When the line of the graph is straight, set the value. So this is the difficult part of this lab. We need to transform by guessing. We do not know, and we know we can never see the same observation exam. So this is the difficult part, and it to practice. So I'm going to do this with a 0.3 and check line. Now, line is look like straight, but if we do different things like 0.4 and 0.6, line will not straight like that. I'm not saying this is a perfect straight line, but if we do different things, then it will not be better. So I'm going to remove seasonality. This is required in this part. Click on transform, then click difference. So for removing seasonality, you need to understand that we use difference. and then we put 2. So here seasonality does not remove. How we know seasonality is removed or not? I'm telling you, when you see the starting point and the ending point and the same point, it means that our seasonality is removed. But now you can see this point is downward and this is upward. We want to see same, so we are going to apply again difference, and I'm writing again 4. First I write 2 and then 4. Now you can see we finally removed seasonality. The starting point and ending point is same, and in exam we need to write the value we use. First I use 2 and second I use 4. I need to write it, and I need to draw a graph in exam to show what I get. Now coming towards part E, regressive and moving average. For this, we need to click on model, then click on estimation, and then preliminary. So we are finding auto-regressive order, AR model. So we need to write 1. And we need to write 0 on moving average. And then click on OK. No, we need to take AR model with min AICC. This is the requirement. So we got our output. This is AR model, not moving average, because we took moving average 0. I'm going to show you again. We took AR model 1 and moving average model 0. So this is our AR model. Now when we need to find the moving average, so we put 1 here and 0 there. And then we need to take this and then click on OK. So we got this. So we in exam, we need to write each and every step what I am doing, and we need to write the answers we are getting. The answer we are getting is AICC value, which is 0.5, and moving average coefficient, and model ARMA model, and their parameters are here. Now our last part for this lab 2, we need to draw ACF and PCF model. Click on statistics, ACF, PCF, and then click on model. 2 graphs will shown. So we need to draw this graph in exam. So I am telling you, in exam, you will get a question like model with different legs. In part F, I am going to show you. Model with different legs. This is the part F. In part F, you need to click on statistics and click on model. So then you will get like this. So I did 2 times, that's why I got different value, but now you got my point. So lab 2 is done. This is difficult lab and you need to do practice. If you have any problem, you can comment. And thanks for watching. I will come back with lab 3.